Hi guys, today we are going to be learning about the unit circle. So the unit circle is really just a tool that we can use in order to evaluate sine, cosine, or tangent, or any of the other trig functions in exact form. It's just a really helpful tool in trigonometry. So the first thing that we're going to start talking about is some special right triangles. So as you know, right triangles have one angle in them that is 90 degrees. And we know these two smaller angles, they're called acute angles, they have to add up to 90 as well. But what makes these ones that we're going to talk about special is that both of these acute angles are the same measure of 45 degrees. So this is called a 45-45-90 triangle. Okay. So the sides are always related to each other in the same way if we have a 45-45-90 triangle. The two legs will always be the same, just like the angles are the same. We're going to look at the case where, where the hypotenuse is equal to 1. So if the hypotenuse is equal to 1 in a 45-45-90 triangle, then the legs are each going to be square root of 2 over 2 in length. And of course that's an exact form, and that's kind of the purpose of the unit circle, is to help us calculate these things in exact form. So this special right triangle is going to help us build the unit circle. And there's also one other special right triangle that's going to help us build our unit circle, and it is called a 30-60-90 triangle. So again, those two angles add to 90. The 30-60-90 triangle has special relationships between the sides as well. If the hypotenuse is 1, which when we're doing a unit circle, the unit is referring to 1 unit, so we want the hypotenuse to be 1. The short side would be 1/2, and the longer side would be the square root of 3 over 2. So if I take a circle and I center it on the origin of our xy plane here, our xy coordinate system, then I can go ahead and use these triangles to learn certain things about some of these functions, okay? Like sine, cosine, and tangent. So the first thing I'm going to do, we know that this starts at 0, goes to 90, goes to 180, 270, and then back to 360. So a complete revolution is 360. If I take and divide or rotate an angle from here, halfway between 0 and 90, that's 45 degrees, right? So I'm going to rotate 45 degrees, and then I'm going to drop a perpendicular down to the x-axis. So now that I've done that, I know that since this one is 90 and this one's 45, well, this one must also be 45. So this is our special right triangle, 45-45-90. Now, in a unit circle, the radius equals 1 unit. Okay. So I know that from the center over here to this point right here is 1 unit, whatever units we would be measuring in. From here out to here on my radius that I just drew, that would also be 1. Of course, my circle's not very round here, but you know, use your imagination. So my radius here, the hypotenuse, is 1, which means because of this special right triangle, I know that this side right here is the square root of 2 over 2, and also that the distance between here and my perpendicular is square root of 2 over 2. I know from here all the way out to the edge of the circle is 1, but when I drop that perpendicular, this section right here, just that side, is square root of 2 over 2. Which means that the coordinates of this point right here, remember we get our coordinates from how far over did we go and then how far up. So our x value is how far over. So the x value here would be square root of 2 over 2. And then how far up, so that would be square root of 2 over 2. So the coordinates at that point are square root of 2 over 2 and square root of 2 over 2. Now, the sine of an angle, remember SOHCAHTOA, the sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if I want to find the sine on this triangle, I would use the opposite side, which is square root of 2 over 2, over the hypotenuse, which is 1. If I wanted to find the cosine, I would use this side right here, right? The adjacent over the hypotenuse. So this length right here, square root of 2 over 2, that side would be related to the cosine because it is on the x-axis and it's the adjacent side. So the x value is cosine of the angle, and the y value is sine of the angle. Now the tangent, because it's opposite over adjacent, it would be like taking sine over cosine. Okay, so we're going to use these in a minute to actually use this unit circle. Now, that is how we get these coordinates here. That's 45 degrees. And 45 degrees, as we know in radians, this is 0 radians, this is pi over 2 radians, this is pi radians, this is 1.5 pi, right, or 3 pi over 2, and then 2 pi. So we can also do the same thing with radians. If I wanted to know the measure in radians, this would be pi over 4, because it's halfway between 0 and pi over 2. So in radians, that's the angle. In degrees, that's the angle, and then these are the values of cosine of the angle and sine of the angle. So this unit circle can then be used in order to evaluate these things. Now we're going to build a lot more out of it, but if I were to take this point here and reflect it across the y-axis, so that we have a 45-degree angle between each of these. So if this is 90 and I add 45 more to that, then this is going to be at 135 degrees. But since it got reflected across the y-axis, it would make the same triangle here. The x and the y value are going to be the same. I went left, but I went the same distance that I went here. So this would be negative square root of 2 over 2 would be the x value of that point. And positive square root of 2 over 2 would be the y value. And then I could also reflect that same point down across the x-axis. And so I know that the coordinates of this point then are the same as these. Just if I'm down in this coordinate, I know the x and the y are both going to be negative. So also the degrees of this would be 180 plus 45 more, right? So about 225, or not about, but exactly 225 degrees. And then lastly, I could reflect it across this way. And this would give me, since the x is positive, it would be square root of 2 over 2, and then negative square root of 2 over 2, because it went down, right? Negative for y. Now, if my circle was actually round, these would line up perfectly this way as well, but because it's kind of got like a dip in right there. But we'll look at one that's actually a circle in a second. So the other thing that we can do here is we can plug in, or we can rotate our 30 degrees here. And that, if I drop my perpendicular down there, that's going to give me a 30, 60, 90 triangle. So that's going to be in here, right? If I were to draw it in there. And so if this is 1, looking at this triangle, the short side would be 1/2, and the longer side would be square root of 3 over 2. So the coordinates of this point, I went over square root of 3 over 2 and up 1/2. Okay, and then that point can be reflected across every direction. Okay. And then I can also do the same thing with a 60-degree angle. If this is the 60-degree angle, then the 30-degree angle would be up here. So this side would be 1/2, and this would be square root of 3 over 2. So that's just how we build the unit circle. Okay. So let's go ahead and take a look at a unit circle that's all the way filled out. Oops, that one's blank. Let's use this one. So this has all of the degrees and radian measures of the angles. Remember, we have 30, 45, and 60. It has the coordinates of each point. Now the edges, of course, are all a radius away from the center. So 1, 0, 0, 1, negative 1, 0, and 0, 1. So these are the x values and the y values of each of these coordinates. These are the angle measures in degrees and radians. And now we can use this unit circle in order to evaluate some sine, cosine, and tangent. So let's go ahead and do that. So let me just get this in the right mode here. Okay, so let's say that I want to evaluate the cosine of 60 degrees. And I can use the unit circle to do this. Remember that the x value, the x coordinate, is our cosine of the angle, and our y value is the sine of the angle. And then the tangent if I want to evaluate a tangent, is equal to the sine of the angle over the cosine of the angle. So I have everything I need then to be able to evaluate cosine 60. So if I go to 60 degrees, which is right here, the x value is 1/2, the y value is square root of 3 over 2, which means the cosine of that angle is going to be the 1/2. So now I can just look at this and tell what the cosine of 60 is. The sine of 60 degrees, that's the y value, is going to be square root of 3 over 2. Okay, and if I wanted to find the tangent of 60 degrees, I'm going to have to put the sine over the cosine. So that would be the same as y over x, right? So square root of 3 over 2 divided by 1/2. Now when you divide a fraction by another fraction, what you're actually going to end up doing is taking the bottom fraction and flipping it over and using its reciprocal and multiplying it by the top one. Okay? So when you divide a fraction by another fraction, take the bottom fraction and flip it over, get its reciprocal, and then multiply it by the top. So square root of 3 times 2 equals 2 square roots of 3. And 2 times 1 equals 2. But 2 divided by 2, that's just 1. So that cancels out. So I would be left with square root of 3 over 1, or just the square root of 3. Okay, so that would be the tangent of 60 degrees. Let's say I wanted to know the sine of 240 degrees. So I would come over here to 240. The sine, I know, is the y value, right? Cosine is x, sine is y. So I would look at the y coordinate, and that would be negative square root of 3 over 2. If I wanted to find the tangent of 240 degrees, I would have to take the y coordinate and divide it by the x coordinate because it's sine over cosine. So again, take the bottom one and flip it and then multiply. The negatives will cancel out because there's 2 of them. On the top I would have 2 square roots of 3. On the bottom I have 2 times 1. So this would equal negatives. Our negatives canceled out. That's an equal sign. So it would just be positive square root of 3. Okay. Incidentally, it will not always come out to the square root of 3. Let's say I wanted to know the sine of 390 degrees. Now 390 degrees is not on this circle, right? It ends over here at 360. This is 360 degrees. So because of that, I have to find a coterminal angle with 390. So remember, to find a coterminal angle, you either add 360 or subtract 360 because that's a complete revolution until you get one. In this case, that's between 0 and 360. So I wouldn't want to add 360 to this because that's going to give me a bigger angle that's going to definitely not be on this circle either. So I would want to subtract 360 in this case, which gives me 30 degrees, which means that sine 390 is equivalent to sine of 30. And if I go over here to 30, the sine being the y coordinate would be 1/2. Okay? So let's say I wanted to know the sine of negative 765. So 765 is not on this. A negative number is not on this. Okay, that means I'm going this way. So in order to get a coterminal angle, because it's negative and I want to get it in between positive 0 and positive 360, I am going to add 360 to it. So negative 765 plus 360 gives me negative 405. Now negative 405 still is not on this, so I'm going to have to add 360 again, which gives me negative 45. And still negative means, I could do it that way now. I could go this way and it would be equivalent here because I went this way to negative 45. Or I can add 360 to it again and get 315 degrees. So I know that sine negative 65 is equivalent to sine of 315 because those are coterminal angles. And so now I can go ahead and use this coordinate right here. Sine is the y value, so this would be negative square root of 2 over 2. Okay. Now let's take a look at some examples that are in radians instead of degrees. So if I wanted to know the cosine of 5 pi over 6, okay, my angle's given in radians, but I can just use the radian measure here. So I see that there's 5 pi over 6 here, which tells me that the cosine is negative square root of 3 over 2. Okay, let's do the tangent of pi over 3. Okay, so pi over 3 is here. The tangent is going to be the sine, or the y value, divided by the cosine, or the x value. So square root of 3 over 2 divided by 1/2. Okay, again, you're just going to invert and multiply. And look at that, I chose another one that came out to the square root of 3 because the 2's cancel. Okay, let's go ahead and try one that is using radians, but that is not on our circle. So we have to find a coterminal angle in radians. So if we do sine of 11 pi over 3, for example, 11 divided by 3 is, 3 goes into 11 more than 2 times, right? So I know it's bigger than 2 pi, because remember, a complete rotation in radians is 2 pi radians. And so because of that, to get a coterminal angle with 11 pi over 3, I would need to add or subtract 1 complete revolution in radians, which is the 2 pi. So here, I'm going to have to subtract 2 pi, because this is bigger than, right now, bigger than our circle. It's going around more than once. So in order to subtract a fraction from another fraction, I have to have a common denominator. And since the denominator here is 1 and this one's 3, I got to get them to match. So in order to do that, I'm going to multiply this denominator by 3, which means I also need to multiply the numerator by 3 so I don't change the ratio. So this would be 11 pi over 3 minus 6 pi over 3, which gives me 11 minus 6 would be 5 pi over 3. Now 5 pi over 3 is on our unit circle, so there's a coterminal angle that will work. So the sine of 11 pi over 3 is equivalent to the sine of 5 pi over 3, which means it would be equal to negative square root of 3 over 2. Okay, so if I have, for example, the cosine of, let's say, negative 13 pi over 4, then I would need to find a coterminal angle with negative 13 pi over 4. So because it's negative, I'm going to have to add 2 pi to it. And then remember, I need to have a common denominator. So I'm going to have to multiply the top and the bottom here by 4. So 2 times 4 is 8. And then 4 times 1 is 4. So 13 pi, negative 13 pi plus 8 pi, that's going to give me negative 5 pi over 4. But I'm still in the negative here. So I'm going to have to add 2 pi again. And since 8 pi over 4 equals 2 pi and has that common denominator, I'm going to add 8 pi over 4 again. So negative 5 pi over 4 plus 8 pi over 4 would be 3 pi over 4. So this is going to be equivalent then to this angle. And since we want cosine, that's going to be the x coordinate. So that's going to equal negative square root of 2 over 2. Okay, so go ahead and try the homework problems on this. And if you have any questions, let me know, and have a great day.